Hello, and welcome to a brief, potentially long overview of how I created procedural generation in Godot using an AStarGrid2D. I don't know if it's AStar or AStarGrid, but I'm calling it Astar. Anyways, I will show you a preview of what I have working here. That's not the preview, that's my level. This is the preview. So I have a 7x7 grid here. And this red space represents a part of the area that's not a part of the grid. Basically, my current level, like playable field, is a 7x7 grid with this corner 3x3 taken out of it. So what I have being done here in this is I have the blue 2x2 represents the boss room for my game, and the yellow represents the starting room that the player will spawn in. I am randomly generating where the blue square will spawn. It'll be either anywhere down here or anywhere up here. As you see, this one spawned up here. Now this one spawned down here. And the player room will always spawn opposite to where the boss room spawns, and it can spawn in any of these three spots or any of these three spots. So it spawned up the boss room's on that side, yellow came down here. The green path you see is randomly being generated from a random point on the blue square and a random point on the yellow square. So this green path here would have had a chance from being like this one could be here, 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 or here. And then the one here could have been here, here, or here. So that's all being randomly generated. And that's basically a main path that will always lead me from the player room to my boss room, because that has to happen. You have to be able to get to the boss to continue on with the game. From that, I then spawned these different colored purple paths that you see appearing. Basically, every purple path is I will call it branch of the main green path. So basically, it's going kind of fast. You'll be able to see here through this preview all the generations. I have it basically just cycling through 100 different iterations every time I load it up here to test for bugs and make sure that there's no invalid pathing. But it basically will, the way it works is it will grab a random position, a random green tile, and then it will start branching out in a random direction. I have it currently set to where it can branch a path up to between 1 and 4 tiles in any random direction starting from the starting green path. It's a bit complicated to explain how it's done, and I'm going to go over the code. I've tried annotating my path as much as possible, or annotating my code as much as possible. I'll kind of explain it as we go through it, but if you want to pause and read some of the notes, feel free. Also, if you want to just copy the code, that's great too. Actually, let me just get the code on the screen while I start talking about it. I'm just going to have this right here as we have our preview going in the background. So before you end up kind of really starting to get into all of this, there's a video I recommend watching first that helped me get started when I knew nothing about AStarGrids, and that is a video by ThinkWithGames. I will try and remember to link that in the description. If I for some reason forget, just look up Grid Navigation in Godot 4.2, AStarGrid2D tutorial by ThinkWithGames. Go ahead and drop a like on his video, because this could not be possible without that video. So I'm going to be skipping a lot of in this video I'll be skipping a lot of what he shows in his video, which is basically how you would set up your atlas, how you would set up your tile set, how you would set up your scene. He goes over all that in his video, so go watch his video to learn all that. Once you've done that, and you've learned kind of the basics of an A-star grid, this will be getting into a lot more advanced things that you can do with the A-star grid and methods and techniques in order to create what you're seeing in the background here, which is a very randomized level generation based on the A-star grid. So first, obviously, I have a bunch of variables here. There's a lot of notes kind of denoting what a lot of them are. I didn't note, and I'm not going to go over what every single one of them is. If you really need to know or want to know, just kind of pause the code or pause the video and read the code. But it should be pretty obvious what most of it's doing. This one right here, this boss room array is basically defining a bunch of areas on the grid. So like these three values here are defining these bottom, so this 2x2, this 2x2, this 2x2, and then the other ones are all these slots. That's how I denote where I want my boss room to spawn. Playroom is basically the same thing. The top one gets the top 3 spots, bottom 3 slots. These right here, all of the different colored tiles from my atlas. This big long array here of vectors is all of the atlas coordinates for my purple tiles, which I use for pathing. I basically just have a bunch of purple shades, that way I can somewhat tell the different paths apart. This whole section here is an array of 16 different mostly 2x2 grids on the areas on the grid, and with the few 1x2s at the bottom. So basically it just starts at the top left and then basically says this is a 2x2, 2x2 here, 2x2 here, 1x2 here, another 2x2, so on and so forth, all the way from the top left to the bottom right. I'll go into why that's needed later. I set a array here with random ranges, and inside of this array I'm basically creating randomizer ranges. So if you don't know what a randi range is, basically it will, if I call on a number for this array, if I say array random ranges index 0, this is basically just going to return a random number between 3 and 10. So I have an array here with random numbers being put out from various ranges at each index. This is a randomized boolean of just false and true. It'll return false and true 50% of the time for each. This one is basically the same thing as the above one, except it turns true 75% of the time. This is the main ready command, obviously. I have it looping 100 times. I'm going to go ahead and just restart this to have it going in the background again, since it'll be kind of helpful as we go over the code. And then obviously I'm calling all of my functions here. The await timer here is just so it doesn't start the next set of, well, that was a full grid. It doesn't start the next one until it's finished putting all the paths in. It's just for visual sake. When you actually finish, or when you're using this in your game, you won't have these timers or the for loops here, obviously. That's just for me, for testing. Here, this is the setup grid. This is more or less the same from what ThinkWithGames did in his video. The only thing that's different is down here, I'm calling my randomize function, which we'll go to that. It is down here at the bottom. So the way that the randomize function works is, well, I guess before we even go over that, I should probably go over the very first function here. So the very first thing I call is I spawn the boss in player rooms. So I do that in this function here. So basically, I pick a random spot from the defined regions in this array. So basically, if you don't know, the .pickRandom method can be used on arrays to randomly pick a value from the array. So basically that's what's happening here. Then this whole set of for loops is spawning the 2x2 boss room on the grid, denoted by the blue tiles. Then I go over this if and else statement determines which side the boss room is spawned on so that it generates the player room opposite. I will then spawn the 1x1 grid, and that's denoted by the yellow tile. Gets a so the next step is to create the entrance and exit points for the boss and player room. To do that, we use this function. So I have a bunch of variables being declared here. Again, I'm not going over what every single variable does, what every single line in the code is. This is just a brief overview. Again, it's not very beginner friendly, and I apologize for that, but it would take just way too long to read over every single line. So pause and read the notes, and hopefully it'll make sense. I'm kind of explaining the notes here myself. Anyways, this loop, this set of for loops here is responsible for getting all 4 boss room tiles and choosing a single tile. So basically, it'll get all 4 of these tiles here. Well, and this one will get all 4 of these tiles, and then it'll basically choose a single tile in this 2x2. Then I run this, which will store every adjacent tile position of the current boss tile. So say it selected this bottom left one. It would have gotten the top, left, right, and bottom of that. And the reason that's important is, for example, this one right here, the right, top, left, and bottom are all of those adjacent tiles are not white. And that's important because we can't set the path like this, the green path. The starting position cannot be any of those tiles because they are not open, right? The boss room is obviously the boss room. The blue tiles, red tile is solid because it's not part of our level grid, and obviously the bottom tile would have been out of bounds. So basically what this is going to is it's going to figure out all the adjacent cells, and then I'm going to run all of these if statements, which basically ensure that the current boss tile selected is has at least one white tile adjacent to it. Otherwise, if it doesn't, if it does, it'll append the current tile to the array, and if it doesn't, it won't append it to array. So right here, I'm basically picking a random boss tile from array of determined good tiles to choose from based on a previous loop. So basically, this array here is what we defined here. We just appended all of the boss tiles that did have a white cell next to them, and then we're picking a random tile from that array, and we're setting that as our boss room tile, which is basically the start room. So this will get all the surrounding tiles from the boss room tile. So let's say after we did all the checking, we determined this top right one is what we want to use as our starting one. We're going to get all the surrounding cells. Then we're going to run this loop for determining which adjacent tiles are actually white tiles. So basically, if it was this top right one, it's going to check all of the adjacent tiles that we just got, and it's going to return only the 2 tiles that were white. So that's what this lambda function does here. It returns only adjacent white tiles to that blue tile. Then right here, it'll officially set the boss room entrance tile, which we will use in our pathfinding with the random white spot from the array that we got prior. The rest of this code is basically doing the exact same thing I just described. You can pause and read the notes, but it's just doing the exact same thing for the player room. Less complicated because the player room is only 1 tile, whereas the blue tile, or the boss room, was a 2x2. Next up, I run setup grid, which is this here. which I think I already went over that before. Oh yeah, I said it's going to randomize the weights. So the way it works is it's going to, before we can actually create this screen path, we need to randomize the grid. So if you don't know, in AStarGrid, when you create a path, it's always going to get the shortest path it can find. However, you can add weights to certain points on the grid to basically say, don't use this, go to a weight that is less than the other one. Hopefully I'm explaining that good enough. So that's going to call this function down here. Now the way that I'm creating this randomization is I'm using a lot of that stuff a lot of those variables I defined above. So I'm going to loop through all of the predefined areas in the grid. So this, when I say the predefined areas in the grid that I'm looping through, I'm talking about this whole grid array of rectangles. That's where I said it was this 2x2, 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 all the way through. So it's getting all of those, and it's going to loop through every single one of those. Inside of every single one, I'm going to pick a random randi range. That is one of these. I'm going to pick a random one of these arrays, or a random index in that array. After I've done that, I'm going to get every cell in the array with this command. I'm then going to basically say if the random area, so I'm basically saying if a point in one of these rectangles areas, if it is equal to a point, which it obviously will because I've grabbed every cell in the grid, it's going to set a weight scale for that point. So it's going to do it for all 4 points in the 2x2. And the way that it's going to set the weight scale is it's going to call the point, and then it's going to set a random number to that based on what we set our current random range here, right? So we picked a random range. So basically, let's say, for example, we called this one randi range 1 through 3. That means down here, this is going to equal randi range 1 through 3. So when we call this method right here, setting the weight scale, the weight is going to be a random number between 1 and 3. And it's going to do that for every single rectangle. Hopefully you kind of get how that creates randomness. So some grids are going to have 2x2s of 7s and 8s. Other ones might have 3 through 4s. Then what I'm going to do to create even more randomness is I'm going to get all of the cells again, and I'm going to use this rectangle that I'm defining specifically. Now this is going to be different based on what your grid looks like. For mine, this is, and it's easier to show here, it is basically a 3x3 area of these 3 tiles here. And it's a little hard to explain the reasoning for that, but basically I can't set any of the tiles out here as solid, and I can't set any of these 3 tiles here as solid, because in the event that all of these tiles were solid and these ones, the pathing would not be, they wouldn't be able to find a valid path. So you're gonna kind of have to play around with your region here for doing this, for setting your solids. But your solids are, this is probably the most important part for creating, I would say, longer paths that like go out of the way. So like here, let me start generating some tiles again to show you what I mean. Like this kind of path, this is only possible with solids. So what it would have done there is it would have set, it's setting solids in this area, which is kind of forcing it to go around those areas instead of through them, if that makes sense. Now back to this. Basically all that's happening here is I'm setting polit. I'm picking a random bool. Remember that one up here, this that I said was a true or false? I'm basically just randomly picking a value from here, which is either going to be true or false. So it's basically saying for every point that's in this rectangle, I'm going to randomly set one of those points to either be solid or not, which means it can't pathfind through that point if it's set to solid is true. Then down here, I'm running two more set poly things on specific points, which is this point down here and then this point in the middle. And I'm basically just saying I'm giving a random value from the random bool true, which if you remember, that's the one that returns true 75% of the time. And the reason I'm doing that for those 2 points specifically is because when those 2 points are both equaling true, it forces it to go around. Like this one, it clearly went solid and solid. It forces it to go further around, right? Because right now it can just usually cut through like that on this generation, but because it's false, we have to go all the way around. So that's one of the crucial points in getting very long paths. My goal with this was to try and get close to about 13 to 14 tiles of green pathing. And sometimes you get short ones like that, but then other times you get long ones like this. Here's another short one that was generated. Obviously, it's kind of a little bit random. This one's a bit of a longer one. I'd say this is kind of the average. This is definitely a very long one. I think the percentage of this is you get a 13 to 14 about 60% of the time. The other 30%, it's probably going to be about an 8 to 10, and then about another 10% you're going to get a 4 to 7 range. So you're going to have to really play around with this kind of randomization settings here to get what you're looking for your specific scenario. This is just kind of a guideline to follow here. So after we've set the randomized weights in our setup grid, it's then going to set the solids of everything else. So this if statement here is important. It's basically because we just set a bunch of randomly solid areas up here in this kind of 3x3 area. We don't want to set, and if you want to know how this is working, this is based off of what ThinkWithGames did in his video. So he explains that more there, but he doesn't have this if statement in his because he didn't do the randomizing. So basically this is setting the red area, my boss room, and my yellow tile to be solid, so it can't pathfind through any of that. But it'll keep the solids we set for the white. Now, the next thing it will do is call the show path function here, which you can ignore all of this. If you want to know what it does, basically it's just it's what's responsible for creating all those test purposes. So basically, after I've done a whole generation, this is just setting everything back to being a white tile so that it can start again. But if you're actually generating for a game like it's released, I don't know how to say it, you wouldn't want any of this in here. This will be problematic. So anyways, all that's really happening here is basically the same thing. I'm passing in the player room exit that we defined earlier and the boss room entrance that we also defined, which was down in this function, if you remember. So that's how we got our start and end point, which is how we draw the green path. So the green path is drawn around all of the solids and weights that we'd set from the randomized weight function. After that, we now move on to creating the maze paths, which I also call the branching paths, the purple paths, basically. So the way that the purple paths work, in my game, I want to have basically, so like, it's hard to do it here with how fast it's going, but basically it'll say you can go out here and here. This one you can go out here, you can only go out here. This one you can go out this way, you can go out this way. This one you can go out here, out this way, out this way. Hopefully that kind of makes sense. This one you go out and then up like that. This one you'll go out and down like that. Hopefully that kind of makes sense. That's the whole point. I don't want none of the maze paths will be able, like the shades of purple, you can't go into those rooms from other shades. I hope I'm it seems confusing, but anyways, the way that I'm doing that, which was probably the hardest part to figure out, I'm doing that in here, this function here. So the way it works is it sets every white cell to not be solid. And of course, I didn't know here this is required because we randomly set this 3x3 grid here. We set some of those as solid. We don't want that to be the case anymore because we're going to need to path in those areas with our purple paths. So that's what is happening here. Then we're going to run a while loop. This while loop is basically set so that it won't break out until every adjacent tile to the green path has a purple path of some kind, a branching path. We don't want a room to not have a branching path. And obviously you can see that this stops once every green path is solved. So not every white square will get filled in. Honestly, if you watch this video and then on your project you figure out how to make every white square have a path, let me know, because that technically is my goal. However, I don't know how to achieve that. That gets very complicated, and I haven't quite figured that out, and I kind of just settled on what I have here. Anyways, so this loop will go, this is going to get the white tiles, this is going to get the green tiles. This following loop is going to return an array with all adjacent white tiles to the green path. So, the reason that's important, I have to run this again. Sometimes a path, like this one here, this corner green tile is not going to have any adjacent white paths. So I have to filter out those specific, like this one. This one, this one, this one. These green tiles won't have any white adjacent paths. The reason it's important to know that is because I'm randomly picking each green path each time. So down here, let's see. Following loops return an array with all adjacent tiles to the green path. Right. So basically this is responsible. This whole for loop here is basically just going to return an array with every green tile that has at least one white adjacent path. And obviously I just explained why that's important, because if I pick a green tile and there's no white path, it's going to return an error. Because it won't be able to path find, obviously. This is going, this right here is responsible for, it basically is just a check. Whoops. It's just checking if the size of the array that we just returned here is 0. If it is 0, that means that basically we've filled in every adjacent tile and we know we can break out of the while loop. Here I'm going to pick a random path, a random tile to start pathing from. So we have our available start tiles that I defined here in this loop, and I'm going to randomly pick one. So it's randomly picking one of these green paths here that we defined as having a white tile next to it. Again, trying to be very random. This loop right here is basically responsible for creating all of the pathing. So I have an if statement here that if it's 0. Also here I'm randomly picking how long the path is. So if it's 1, that means the branching path is only going to be one room. It's only going to branch off one room. If it picked 4, it has the potential to randomly pick 4 tiles. I don't think I've really ever seen a 4 branching room. They're rare. They can't happen, but they are rare. And the reason for it being rare is because of the randomness of it, which I define down here. maybe here? Yeah, here. So the way that it works is after the first one, if it's 0, I basically only want to do this and then move on. But if it's more than 2, obviously I'm going to keep move on, and I'm going to keep pushing out the paths. And the way that that kind of works is I'm grabbing all of the white tiles, and after I've got the white tiles, I'm getting the surrounding cells of my current position. So let's say that this position here, how do I say this? It's getting a point, and it's after. So I've created my first room. It's getting all the surrounding tiles of the first room that I've created, the first branching room. The reason for that is it needs to filter out all of the adjacent tiles and only return an array with adjacent white tiles. Again, there's a theme here. It then will basically pick a random tile right here. It picks a random adjacent white tile to the current purple room, and it will create a room there. Now, this is important here. If there was no adjacent white tiles, it's going to break out of this whole loop here. That basically means, like, for instance here, say that the range was 3. It wanted to make 3 rooms, but there was only 1 space available. Like, see here? There's only 2 rooms available. So it can't go more than... It can't complete the for loop range. Hopefully it makes sense. I don't need to keep elaborating. This down here is basically just bumping up the current color for my purple atlas array. That way I get a different shade of purple every path I make. It's just easier to see, and I think it's going to be important for when I need to start assigning my actual scenes that correlate to the paths themselves. Haven't gotten that far yet. I might make a video once I actually do attach all of my scenes that correlate with the nodes and connect all the corridors, because I know that's just going to be just as complicated. I might make a video when I do that. But so far, that's up to you, because I'm not explaining that in this video. But anyways, I think that's it. I think that's basically everything. After that, this await timer here basically just says start it all over again. If you have any questions, leave a comment. Keep in mind, I'm a beginner myself. I kind of had to learn all this from scratch, so there are still things that I do not know. I will do my best to try and potentially figure out the answer to your question if I don't know it, and help answer it the best I can, but I don't know everything. But obviously feel free to ask a question. I will try and help out as many people as possible. Even if this video is 2 years old, I plan on still being here. So hopefully my game's released in 2 years. Anyways, leave a question if you have it. Otherwise, drop a like on the video if this helped you out. And I look forward to helping you out next time. Later. See ya.